Welcome back to the main auditorium, where we are delighted to begin the Quantum Technology and Innovation track. To moderate our first talk in this topic, I am thrilled to introduce you to Silvia Zorzetti. Silvia is a senior engineer at Fermilab, and she is currently deputy head for the co-design department at the US National Quantum Information Science Research Center. She joined Fermilab in 2017 as a Bardeen Fellow, and during her PhD in Electronics, Engineering and Information Technology from the University of Pisa, she was a Marie Sklodowska-Curie Fellow at CERN. Thank you, Silvia.
Thank you for the introduction. I'm delighted to be here with you all at the second Collisions, and it is an honor to introduce the next speaker. In fact, it is quite rare to meet someone like Markus Flitsch, who is an expert in both the scientific and financial sectors. Markus is a co-founder and chairman of Terra Quantum AG. He is a quantum physicist and CERN alumnus. He is also an experienced senior financial executive and deep tech entrepreneur. He's a graduate physicist. As a graduate physicist, he began his professional career at the Boston Consulting Group in Europe and North America, and went on holding several top management positions like CEO, CFO, COO in international financial corporations like Deutsche Bank, UniCredit, as well as owner management, digital and high-tech companies. Markus is the co-owner of a large German multifamily office and a senior advisor to private equity funds. He is also a member of the BBUG, which is a German institution which helps cultivating the next generation of executive leaders by bringing together discussion makers from business, politics, and societies. The title of Markus' presentation today is From Physics to Finance and Quantum Tech Frontier. Markus, please, the stage is yours.
Thank you, Silvia, for the very kind introduction. And I'm very happy to be back at CERN. Actually, I'm looking back now at my active time at CERN 25 years later. So it's really great to be back again. And today I would like you to lead you a little bit through my journey since my time at CERN, then into financial services and investment banking, and then finally, founding one of the leading global quantum tech companies. So I'm very happy to be here and to share my experience. This picture actually is not 25 years old. It's actually very recent, just before COVID. I invited 60 top executives from large German corporations to visit CERN, to go underground and actually to experience CERN live and see the experiments. And I can tell you that they have been all blown away by that experience. Although they are very experienced executives, they have never been there before. And for me, it was great to see actually that, what they impressed so much is still there, and it's kind of the same what has very much impressed me back then 25 years ago. So I think that is a sign of a very strong culture CERN has, and that's also why I'm still a very proud ambassador of CERN, that great organization. To let you know what I did in terms of research back then, I was researching the field of quantum chromodynamics, actually. Some of you might have heard running alpha S, and I was actually measuring running alpha S at rare events where the electron or the positron, back then it was still lab, as you know, and I was working at the Opal experiment. So therefore the electron or the positron radiated a photon before the collision, and therefore I was analyzing events at a lower energy, and therefore could find a measurement for alpha S at low energies. So that's what I did back at my time at CERN. But actually, the key learnings or takeaways from my time there were, of course, a little bit more general and didn't have so much to do with running Alpha S. I think what was more of a kind of general impact are three things. First of all, during my time, actually, the internet era actually kicked off, and you know that CERN has been instrumental. We all have worn those T-shirts, www.cern.ch, where the web was born, and I personally think actually that this, if you will, spin off from CERN was a great achievement, and it showed me, how exponential innovation can actually change the world. And the approach of CERN to really tackle the big questions and to support big innovation jumps really made an everlasting impression to me. And then secondly, the whole culture and philosophy of science for peace, the open atmosphere, the international atmosphere, I think have been very important to my life because it showed me that if you have the same passion, if you share the same goals, in that respect, the same scientific goals, that really unifies the world. And last but not least, it was actually that really global and diverse culture which impacted me a lot, because back then, that was mid of the 90s of the last century, CERN already was a truly global organization, and it is of course very impressive for a young person to see kind of people from all parts of the world working together in a joint project for a joint goal, regardless of their very diverse backgrounds. So I think these were actually the impressions which actually really had an influence on my life. And I then decided, after my time at CERN, to do something completely different, because I wanted to have the complementary experience, actually. So I decided to join a strategy consultancy, Boston Consulting Group, and went from Europe to North America, and actually were able to do decisive work, let's say, in the first wave of digitalization. It was the dot-com bubble back then, and everybody wanted to work in e-commerce and in the evolving and emerging internet space. So I had the chance to do that at BCG, and therefore it was kind of great to see the continuity from my time at CERN, where actually the web was born, and then actually to work on commercialization strategies of the emerging internet. My time at BCG then led me to focus on financial services and investment banking. So therefore, consequently, I joined Deutsche Bank and worked in investment banking since then in the M&A area. And that was also a very good and steep learning curve. At the beginning of the last century, there was a lot of M&A activity, actually. So it was a tremendous times. And as with BCG, I was able to look into various industries and verticals, and therefore learn a lot in terms of the global economy. I then, and also here that was a decisive kind of turning point in my life, experienced the financial crisis in 2009, Lehman crisis, and decided to leave banking to work actually in very operational roles as a chief executive officer or a chief financial officer in companies who were backed by private equity funds, leading these funds to an exit. And here, I think I gained the experience to actually also lead the company and make decisive changes for the future development of these. And that then altogether led me to the conclusion to actually put together, combine those kind of two sides of my brain, if you wish. So my education in physics, my time at CERN working as a quantum physicist, and then also using kind of the next 20 years of my career, where I have been in financial services, in corporate finance, in kind of the commercialization space. So I thought it's a good time actually to combine those two experiences, and so I founded Terra Quantum. Terra Quantum is a Swiss-based quantum tech scale-up company. It today employs around 100 quantum physicists and mathematical physicists. So it's one of the largest global teams in that space. And we are actually developing solutions and applications for quantum computing. Let me tell you a little more about that. You all know Richard P. Feynman, one of the great physicists and Nobel Prize winner. He, in the late 80s, actually said, nature is quantum, so if you want to compute like nature, you should actually do quantum computing. And that actually kick-started the development of the quantum computing era and the first kind of hardware activities in that space. And for me, it's really fascinating that the basic principles actually of quantum physics, which we know now by almost 100 years, are the decisive basic principles which make a quantum computer work. Especially the combination of the two principles you all know through your studies, superposition and entanglement. The combination of those two actually creates the exponential speed up of a quantum computer. And that is why this technology is so disruptive. That's why I personally think quantum tech is the most disruptive technology for the next decades, actually. And it will disrupt, I think, almost all verticals, because everything which has to do with simulation and optimization and machine learning will be, enhanced and upgraded by quantum applications. And if you can rely on an exponential speed up, you will soon be able, once you have the hardware which has enough qubits, you will soon be able to calculate and optimize things where today's supercomputers would take longer than the lifetime of the universe, actually. A future quantum computer, which is powerful enough, will do that in a fraction of a second. And I think this illustrates the disruptive power quantum computing will have. And that's why it's so thrilling to work in that space. And here you see how our company is organized. We actually operate in 3 business units, but the unifying theme is that we are an end-to-end quantum as a service company because we want to tackle real life use cases and make an impact into the corporate world already today. And I will show you that this is actually possible with today's technology already. So we develop quantum algorithms and provide them for industry use cases. And then we also bring the hardware, that's our second pillar, quantum compute as a service, where we can actually deploy those algorithms and make a difference today already with migrating quantum algorithms or traditional use cases into the quantum space. And then our third pillar is quantum safety as a service, where we develop leading quantum cryptography solutions as quantum will will make it necessary that kind of all data security is upgraded to a quantum safe level. So let me go into each of those dimensions to give you a better understanding of what we do here. This actually is an example of a quantum algorithm which is based on a hybrid quantum neural network, and that one serves for better image recognition. And as you can see here, this you can use in e.g. autonomous driving for the automotive industry. But of course, better image recognition you can also use for various other verticals like robotics or medical diagnostics. And that is actually the power of the underlying quantum algorithms, that you can use them for multiple use cases in various industries. We recently developed a quantum algorithm which is used for collateral portfolio optimization within investment banks. And we could show that based on real data, that if they migrate their classical optimization algorithm into the quantum space based on the quantum algorithm we have developed, that they will save 120 million euro annual recurring cost. So that really means that has a huge business impact if you can save costs in the order of more than 100 million each year by just migrating one single use case into the quantum space. And that is actually achieved already today using our quantum algorithms, but also our hardware, which we provide. And I will show you how that works. And we join kind of the second business unit of Terra Quantum, Quantum Compute as a Service, where we do our hardware projects. The current era of quantum computing is called NISQ era. So we have NISQ devices, that's noisy intermediate scale quantum computing devices. And you call it like this because those qubits or the QPUs are very noisy. So you have to error correct, and therefore the real performance of the available chips, e.g. the 55 qubit from IBM, is much lower, right? And therefore also the quantum volume, which is a measure for kind of how complex operations you can actually carry out with a quantum computer, is still very low. And that's why in that era of quantum computing, we are actually using classical high performance computing architecture, which we compose in an IP relevant manner, to virtualize qubits. So we work with so-called logical qubits, and those logical qubits have no errors. So you don't need to error correct. They have no noise. They are highly performant. And that's why with our machine, the QMware platform, which is accessible via the cloud, we have a quantum volume which is much higher than all available kind of true QPUs. And that makes it possible that we achieve those business impacts, which I talked about earlier, already today. And that is decisive because to gain commercial traction and to have successful quantum use cases for the industry is very important, so that the industry really kind of enters into quantum technology and is not waiting kind of years until we have real QPUs which are higher performant. So with that compute power, actually we tackle a lot of use cases, and the corporates can access our platform via the cloud and can experiment with their own developed quantum algorithms, or they join forces with us and we co-develop such algorithms. Let me jump to the last business unit, and that is quantum safety as a service. And I would like to talk a little bit about data security. We all know since Peter Shor and his great algorithm that every classical encrypted code will be hacked by a future quantum computer which has enough qubits. So there is no real quantum safety in classical encryption. And that's why actually the industry has to upgrade to a quantum safe level. And we actually made some breakthrough contributions here. First, we were able to show that we mathematically could reverse the hash function, and that means that we could break various classes of classical encryption algorithms with a quantum computer, and that includes AES, the Advanced Encryption Standard, which was so far being reviewed as a quantum robust encryption algorithm. And this also has a lot of consequences, our work, which we also, to mention that, can't yet practically execute because we don't have the hardware yet which has enough qubits. But it has a lot of consequences because it means also that all existing blockchain protocols, for instance, are not quantum safe and therefore are vulnerable once the hardware is there to execute our protocol. And that means there is a quantum threat to organizations. And that's also why recently an expert of the industry said, prepare for the quantum hack now. You have to upgrade data security to the quantum level because you can't wait until the hardware is there because then it is too late. Therefore, we put a lot of effort in the development of a truly quantum encrypted protocol to exchange data and to communicate safely. And we were able to develop a protocol based on fast quantum key distribution, which, because we have a revolutionary approach here in sending a bunch of photons instead of just one photon, we could actually achieve a long distance, fully quantum secure data exchange. And we can also work with existing optical fiber infrastructure because we got rid of so-called quantum repeaters or trusted nodes along the line, which is a tricky thing to do because of that bunch of photons which we send. So therefore, we can work with existing fiber combined with commodity optical amplifiers. And that makes it very powerful because fiber infrastructure is there and is installed, and we don't have to wait for a future satellite infrastructure, which, by the way, our protocol also works. But a satellite infrastructure has a lot of unsolved problems, e.g. the satellites have to act as trusted nodes. You have some last mile issues here, and it's, by the way, very costly and still, 10 plus X years down the road. So what we created is actually an implementable protocol, and that's, of course, also very thrilling. And also this is a very commercializable product because, as I told you, you have to make sure that you are quantum safe before the hardware is there. And actually, if we look at the roadmaps of some of the hardware developers, we can see that this might happen pretty soon, as there are some revolutionary technologies underway which could get rid of the mechanical challenges. And therefore, I expect that we see some innovation leaps actually on the hardware side, which will make it able to much faster scale the existing numbers of qubits and make them higher performant. So that was kind of a tour d'horizon about what we do at Terra Quantum. And also was kind of an overview what I did since I left CERN, with kind of going into financial services and then using that experience to actually combine it with my scientific experience to build a leading quantum tech company. And I think that is, of course, very thrilling if you have the opportunity to actually make use of all what you have learned so far in your life. With that having said, I think we are moving towards the Q&A section, and I'm very happy to answer some questions which you might have. Thank you.
Hello, Marcus. So thank you for your presentation, for sharing your experience, telling us about your journey from particle physics to finance, and of course, like landing to the quantum computing world that we are all very passionate about in this, in particular in the last years. So I'm reviewing, I don't see any question right now from the audience. So if anybody has question, I think you have a link to share your question. So please go ahead. So before I receive question from other people, I have let's start with the tough question, like the biggest question right now in the quantum world. So from your perspective, what is quantum computing next big challenge ahead?
Of course, the hardware development is decisive. We see that with the current leading kind of hardware typology, which is usually based on superconducting qubits, you have those mechanical challenges actually to scale them and to get the performance higher, so that you have to error correct. So to get really scalable a scalable qubit platform, I think is decisive to kind of enter into that exponential speed up of compute power. But I see very promising, hardware efforts which actually have a wide range. I mean, we have it from the superconducting level towards room temperature based on photonics, and I'm pretty sure we'll see some great innovation jumps here. And if some of these technologies actually work, we could be all surprised how quickly then those hardware will scale up. And that, of course, opens great doors for applications, optimization and simulation challenges, which we can tackle, which we haven't kind of thought before, or which will be absolutely, which will mean absolute breakthroughs, I think, in the way we can optimize and simulate things.
We have a question from the audience, from Virko, I think. So what did you mean about hardware simulated qubits? If you can clarify this.
Yes. So our platform currently doesn't work with kind of real qubits, where you have a qubit which is cooled down to superconducting level and then kind of works. But our virtualized qubits are based on classical high performance computing architecture, but they are composed in an IP relevant manner, e.g. how we access the memory or so, to get kind of that simulation right, that you have kind of superposition and entanglement, so to say, at work. And you will not be able actually to simulate or virtualize, let's say, 100 qubits, right? The memory you would need is just too much, and it would be a contradiction to kind of an exponential curve, right? But in the current NISQ era, actually, you can do that. And e.g., 40 logical qubits, virtualized qubits on classical HPC, have a much, or at least our machine, much higher quantum volume, kind of a measure for what complex calculations actually can you carry out on that machine than the kind of real QPUs. We all hope that this advantage goes away very quickly and that we can switch on and integrate QPUs, which are much more performant, so which don't need that high error correction rate.
Yeah, and we are working on this. So
yes.
So one more question. So you mentioned object detection in autonomous driving. What is the main difference between these quantum algorithms and some classical algorithm for the same scope?
Yeah, the major difference actually is, the quantum algorithms are based on Schrödinger's wave equation, right? It's kind of real quantum physics at work, and that also means why that currently in that industry you really have to be a quantum physicist to work in that space and drive it forward. Yeah, that's actually a great chance for physicists, I would say. On the other end, that also means that you need quantum physicists, that you have to cope with the scarcity of global talent. So I can only encourage everybody to go into that field of particle physics, quantum physics, because the industry will need thousands and thousands of more quantum physicists working on that disruptive field in the future. And now, especially on the hybrid quantum neural network, which we built for autonomous driving, this is
hello?
This is a
hello. Hey.
This is an algorithm where
hey.
Where the neuron is encoded with a qubit, so it can have more values than just one value.
Okay, thank you. Sorry, there was a problem with the audio at some point. So can you share with us more about hybrid hardware and how this can increase the quantum volume?
Well, that actually goes a little deeper, so to say, in the technical layers of that virtualization layer, which I think would. I'm very happy to do that kind of offline, because you really would have to dig deep into our compute stack here, how that works, and it's actually also kind of patent based how we do that. But you can, I mean, there are other simulators out there where you can kind of do that, but it has a certain limit. And the differentiator with us is that we have a fully operational stack, which you can actually access via the cloud, and that we have APIs to all relevant systems. So what you can do with us, you can really have your quantum algorithm deployed, accessed via the cloud, and then deployed on our machine. And we are not depending solely on those the logical qubits. We can switch, we can act as an integration hub for real QPUs and switch between them. Yeah, but the operational stack is built in a way that it is more or less hardware agnostic. So currently we work with those logical qubits, but we could switch to real QPUs when they are better performant.
Okay, thank you. So one more question from me. So quantum computation science is a source of new technologies, and that we have governmental institutions that have joined the challenge and are supporting the field. And at the same time, there are industries that are emerging. There are several startups, and there are also well-established industries like big stakeholders that are in the field. So from your perspective, still, as someone that comes from CERN as government and now is in industry, what is the balance, or what is how do you picture different roles between these entities, government and industry and private sector?
Yeah, I think, and one would have to differentiate in the private sector. I think probably the big tech companies and the kind of the emerging ecosystem of quantum tech startups. For the latter, I mean, it really means kind of a little bit of mind shift. Yeah, as a scientist, you are very open and you prepare everything and you put it on archive and you publish it on Nature. If you are a commercial company who has institutional money backing it up, you of course have to protect your IP. So what you develop is usually yielding to a patent. So we file a lot of patents because this will kind of help us to defend those future markets. And I think that is a decisive difference, that we kind of are shifting from kind of a scientific publication mode towards the production of commercializable products. Yeah? But as much as we can, actually, as we want to actually really foster that industry, we actually put our developments on archive to actually help to boost that emerging industry.
Thank you. We have to wrap up. So one second question. What is your advice for young scientists and researchers that are listening to us?
I can say, I mean, if I would back at CERN, I couldn't say how my career would evolve. So it looks kind of so naturally, but it wasn't. I mean, looking back, I would say getting into physics, especially working at CERN, was one of the greatest decisions in my life. First of all, I'm so curious and I wanted to understand how life works and how the universe actually works. So physics is a great place to think about that. And with working at CERN, I think one is prepared for almost everything in kind of in an industrial career. The physicists, what we learn, I think, is you can use that in so multiple occasions. By the way, e.g. with BCG, I think the best performing group within BCG are actually physicists. Yeah, so I think it's a great preparation. I can only advise continue that path, and if I may allow, I think especially quantum physics has a great and bright future, because around quantum computing we'll see a lot of disruption in various verticals, and therefore more quantum physicists are needed, I think.
Okay, thank you, Marcus. Thank you all for listening to us. I think we had like a great lesson, a lecture on how to merge physics and the financial world. So I think we are good here, and let's go to the next speaker. Thank you.
Thank you.
Hello again. Now, continuing the quantum tech and innovation track, it gives me great pleasure to introduce our next moderator, Lars Andreason. Lars holds an MSc in Entrepreneurship and Business Development from the Norwegian University of Science and Technology, NTNU. While writing his thesis, Lars worked in the CERN Knowledge Transfer Group as an entrepreneurship development student, with responsibility for hosting meetups for the entrepreneurship community at CERN. Lars is currently the CEO of Streddy, a startup that enables brands to build a loyal customer base by encouraging physical activity. Lars comes from a prior career in journalism, focusing on long-format radio, such as documentaries and podcasts, as well as science communication on YouTube. He still moonlights as a podcast producer when his schedule permits. Over to you, Lars.
Thank you, Andrew, and welcome to the talk Entrepreneurship at the Quantum Computing Frontier. You said most of it, but my name is Lars, and I'm the moderator of this event. I left CERN in 2019 to start working full-time in my own company, Streddy. While at CERN, I worked in the knowledge transfer group, encouraging scientists and researchers to explore the opportunities of building their own companies based on the research and know-how they acquired at CERN. For that reason, I'm very happy to introduce the speaker for this session, Yuri Anderson, who has done just what I try to inspire people to do, namely transition from research to entrepreneurship. He has co-founded several deep tech companies and is currently the CEO of Angoka, a cybersecurity startup. Furthermore, he has contributed to spinning out tens of quantum and deep tech companies through his work at both Nobla Ventures and as entrepreneur in residence at the UK Quantum Technology Enterprise Centre. After Yuri's talk, we'll have time to ask him some of your questions, so please don't hesitate to submit whatever you should have in mind in the chat during his talk. Without any further ado, live from his home office in London, please welcome Yuri Anderson on Entrepreneurship at the Quantum
I've lost the sound though. Yes, hello everyone. I hope you can hear me. I think I've lost the sound on my side, so I hope everything is okay. But it's a pleasure to be here and to be reconnecting again with CERN, which I've had some fantastic times at, and I'm going to talk a little bit about entrepreneurship at the quantum technology frontier. So not just computing, but quantum technologies in general, and I'll get into that in a minute. Just a little bit of background to myself. I started out my career in Sweden. I went to Linköping's Technical University in Sweden, where I studied applied physics and electrical engineering. And once I'd gotten through my undergraduate degree, I ended up at Stanford University, where I studied more and more of physics, and I started getting into more theoretical physics. And this is how I ended up at CERN, eventually actually going back to more applied physics at that stage. And this was way back before those days, before the days of the LHC. We were still building the LHC back then, and I had to dig out an old diagram of what CERN looked like back in those days. But I was working at the PS booster. I assume it's still there, but I'm not 100% sure. But the work that I did there was involved looking at the beam transformers because they needed a significant upgrade for the LHC. So I spent quite a bit of time in my lab that I had at the booster looking at various magnetic materials and try to find out the best ones to get that improvement in sensitivity of the beam transformers. So it was a fantastic experience overall with CERN. It's a unique environment to be in. Just the caliber of people that you meet, the kind of conversations you have, the multilingual conversations you have over lunch, and just the social life as well. So I had an absolutely fantastic time. I don't think it's an exaggeration to say that I was probably one of the best years of my life. So that gives me a double pleasure today, I think, to be back here and talking to all of you. What I did after CERN was that I went to Cape Town in South Africa and started working on cosmology to do a PhD on that. And at that point, I got back to more theoretical concepts. I was looking at things like large-scale structures, so looking at the distribution of galaxies in the universe, and based on that, trying to figure out some constraints on certain cosmological parameters, such as the background density. And it was very interesting. To me, at the end, it was bordering a little bit on philosophy, to be honest, because some of the things that I was working on, I had a feeling I wasn't entirely sure whether that related to my everyday life, and also in my research, I came to certain results which made me start to wonder and question some of the basic principles of the standard model in cosmology. And I just saw an article a couple of months back from some of the people I used to work with back then, who actually now started to point out these things. And it's very exciting. It might mean that there is a new line of investigation for cosmology. So it's very exciting for them, and I'm glad they continue working on it. But for myself, what happened was that I was on my way from South Africa to the UK to finish off some of the research that I've been doing, but ended up in a pub in London with a few people who were working on a fintech startup that involved building a new trading platform. And this was very groundbreaking stuff back in '97. This was at the height of the dot-com boom, sort of a lot of digital startups coming through the ranks. And this was a financial technology one. I was very interested in this because through my student time, because I'd moved around quite a lot, I had some small pots of money in various different currencies. So I'd have written a little application to revalue those currencies. And as it turned out, these people that I met in London, they were working on a professional system to do this. So I got very excited about that and joined that startup. And I spent a bit of time on that. It went well. The company eventually got sold. I did another fintech startup along the same lines, again, trading platforms. And as a result of that second one, I also ended up in investment banking, where I spent another 6 years. Now, this was a very different kind of experience. This was a large bank, lots of people, bigger budgets, and very different from working in a small, agile startup. And after a while, I felt that I wanted to go back into that startup world. There was something about coming up and innovating in a different way that you can in a bigger organization. So I left the bank. I started working on startups again, did a little bit of investment, some angel investment, some property investment. I also did an executive MBA, which was an interesting experience. Now, I often get the question whether it's worth doing an executive MBA for entrepreneurs. And as I'd say, the answer to that depends. For me, it was a good thing because through that study program, I think it just consolidated a lot of my experiences. It put some structure into it. and gave me a more professional vocabulary to use as well in business. So for me, it was useful. But I can also see the other side of the coin, which is that there is a certain amount of overlearning when you do a study course like that, and there are things that you can only really learn by doing, and which is usually the entrepreneurial approach. So I don't think there's a one size fits all answer to that, and it really depends on your circumstances. But what I ended up doing a few years back now, 5 years, going on 5 years back, is that I helped set up the Quantum Technologies Enterprise Centre here in the UK, out of the University of Bristol. And I was the entrepreneur in residence and still am. And what we did at QTech was that we took in scientists, mainly quantum scientists, but we took in other deep tech or other scientists as well who had entrepreneurial ambitions, had some ideas, had worked on some interesting intellectual property, and wanted to take the next step to spin out these companies. And what QTech does is that we take them in, we put these scientists through a one-year program, which includes business training, lots of mentoring, very hands-on. So we call it an entrepreneurial mini MBA for scientists. And going back to the point that I made previously, we take those the key elements of an MBA and put that into that training program, but we also do it in a very streamlined manner. So it's very hands-on, with the view really to spin out companies at the base, the back of that. And it has been a very, very successful program. We've spun out 27 companies to date, and we have created over 170 new jobs. The portfolio companies have raised a collective 65 million euros. I think it's actually a little bit more. I think the figure is a little bit out of date. In fact, that 1/3 of the UK's quantum startups have been founded through QTech or had some affiliation to QTech. So it has been a very successful program. And I'm just going to give you a few examples of some of the companies that have come through the program. So one of them is KETS. They build QKD systems, quantum key distribution systems. So this is now looking at providing those quantum safe and quantum secure exchange of encryption keys, which is using photons for exchange of information, and based on the properties and the statistics that you build up on the receiver end, you can figure out whether there's been an eavesdropper in a way who's been picking up some of those photons or not. So this company, they have now been around. They came through the first round of QTech. They are now at Series A level. I think they've raised something like 10 million pounds or euros. And they're really well underway. And it's a great pleasure to see companies like that who are now starting to become very, very professional. They actually delivering products. Is no longer science experiments on a lab bench, but they're actually cranking out real life products that clients are willing to pay money for, which is absolutely fantastic. And but we have a range of companies that have come through the ranks of QTech. Another company is Fluoretic. Now they're using very different technology, but they're using quantum dots, and they use this for medical purposes. So they are able to detect certain pathologies in blood samples. For example, they can detect infections of the blood, for example, and this allows them, or the medical services, to provide more targeted treatments for this, and can detect things like sepsis, which needs very, very quick detection. And they also came through the first generation of QTech companies. From the second cohort, we have a company called Seek. SEEQC. They are a quantum computing company. So they build a full stack quantum computing platform. So they do everything from the hardware, superconducting hardware, and provide, with the aim to provide a quantum computing as a service solution for people to be able to leverage off that quantum computing hardware. Another company is Vector Photonics. They are building lasers that have some very unique properties, and they spun out of this current cohort, which is very exciting, and they've done very well and raised already a couple of million in investment. So they're well underway. They are based up in Scotland, and we see great applications for this technology, both in terms of optical communications for data centers, also satellite communications, and so on. So very exciting company. Going down the list, another company is Aglaya. They again use sugar-based quantum dots that they use to enhance the plant's photosynthesis. So this technology is something that they can use to spray on plants in order to get a higher performance in terms of growth of these plants, so they can get more crops and biomass quicker by doing something very clever. So they take some of that light that comes from the sun and convert that into more blue light, and this is something that is used for photosynthesis. And it's surprising actually that only 1% of the sun's light is actually being used for photosynthesis. So this technology is something that can enhance that, and obviously this has got great applications, and they've proven that they can improve yields for wheat, for example, and strawberries and other types of crops. So this is an agri-tech type company, which is it's nice to see. A third company that went through QTech, this is just to show really the versatility of the program. It really is all about deep technology, not necessarily just quantum, but ICOMAT build technology for carbon fiber steering. So this is mechanical engineering, really, material science, where they have developed a method to be able to bend carbon fibers, which has not really been done before. And because they can do that, they can save a lot of weight for example, aircraft that are being built using carbon fiber. So it's another very exciting company. And as you can see, there is a huge variety of the companies that have gone through the program. I'm going to talk a little bit about the companies that I've gotten more involved with. Part of the role of being entrepreneur in residence is also to get more involved, if you want, with some of the companies. And I have. So, for example, there's a company called New Quantum, which is a spin out from Cambridge University. And that is a company I got a little bit more involved with, and I'm considered one of the co-founders of that company. This is a company that builds quantum photonics components. So this is based on some IP that was developed from University of Cambridge, where they've developed a very unique single photon source and a single photon detector as well. And this is something that the company is now commercializing and building into various quantum photonic systems. They can be, for example, QKD systems. They can also be sensors, or even quantum computing or quantum networking even. So it's a very versatile photonics technology, a single photon technology. Another company that is using single photon detectors is QLM, which is a spin out from University of Bristol. And I also helped start that company as a co-founder. That is a company that uses single photon detectors to detect methane. And this is great because there's a huge need to detect greenhouse gas emissions from, for example, gas distribution centers, gas power plants, and so on, to make sure that there is no leakage of methane, because obviously there's the greenhouse gas effect on it, but also methane, you can imagine, is a combustible gas, so you don't want to have any leaks there because you can cause accidents. So QLM has built a very, very sensitive and very cost-effective as well technology camera that can monitor installations for gas leaks. And this is something now we're seeing this being commercialized and actually being used out in the field. And it's very cool. You can put them on drones, for example. They're very lightweight, so they can fly over things like gas pipelines and monitor for leaks. So very exciting. Also helped co-found a company called Cryptolabs, which are building a quantum random number generator based on photonics technology again. And that ties into another company that I've also co-founded. Now, this is not at all quantum, although there is a quantum application for it, but there's a company called Angoka. So this is a cybersecurity company that looks to secure machine-to-machine communication. And it's interesting from a quantum perspective, actually, because as it turns out, a little bit by accident or serendipitously, the technology that Angoka employs can very nicely combine with quantum key distribution to address some of the shortcomings with QKD. For example, very low key exchange rates, and also the distribution of quantum secure keys or quantum derived keys over wireless. Of course, you need to have, for QKD to work, you need to have some optical connection, whether that's fiber or free space. But how can you get quantum keys out over a cellular network such as 5G, for example? This is something that Angoka is addressing. So it's a different type of company, but interesting nevertheless. So as you can see, I take a portfolio approach to entrepreneurship, and that all happens through my sort of innovation consultancy, Nabla Ventures, and that's what I do. I get involved with startups. I help co-found them. I help bring them up, get them funded, get them up and running, and so on. So just a few final words. Entrepreneurship can be extremely rewarding, and I think it's a very valid career path coming from science, but it's not for everyone. And if you're interested, I would just encourage you to try it out in a sort of safe environment. Go to one of the very many accelerator programs or pitch events and so on, and just try it out and see what happens and see if you like it or not. The statistics are frightening. They're really bad. Only 1 out of 10 startups succeed statistically. But what's really, really important is to find the right team. Work with the right people who can complement you, your skills, but share your ambition. And also very importantly, learn from others. Get a mentor. Talk to them, make the most of it, ask them questions, make sure you don't repeat the same mistakes that other people have made, and make use of the many accelerator programs out there. And hopefully then you can significantly improve those chances of success. So with that, that's all I had in a way of presentation. I think now there is a Q&A.
That's right, Yuri. Thank you so much for your talk. The first question is, some quantum use cases still require many years of research and development before they're commercially viable. Tell me about how financing works for quantum startups. What are your sources, and what kind of timeline does it give the startups in terms of a road towards commercialization, let's say?
Yeah, great question. So it depends a little bit on what type of quantum technology you're looking at. So certain types of technologies, such as detectors, for example, that use detector technology. I mentioned one of the companies there, QLM. This is commercializable right now. So to get funding for that is not impossible. I was going to say it's easy, but it's not easy. It's never easy to get funding, but it's certainly doable. If you look at quantum computing, which is at the other end of the spectrum, which is we're still probably a few years out. Interestingly enough, there's quite a bit of funding going into it, and there are companies who have raised hundreds of millions in funding because it's such a big problem and there's such a big price. If you manage to crack this, you can be at the forefront of a completely a new technology, a revolution, and you can solve problems that nobody has been able to solve before. So surprisingly, perhaps, there is quite a bit of funding going into that. But as a general rule, you want to be able to find a nice mix of grant funding, because there's also a lot of grant funding out there. So particularly early stages, to mix and match quite a bit of grant funding plus some private investment. And it's in that mix you can get that longevity that you need in order to develop your technology and your products.
Okay, I hear someone coming into my office, so I might be disrupted soon. But I'll set you off with another question first, and it kind of builds on what you already said. Quantum technology, at least at the a research level, is still it's a magical technology, but it's what you call tech push, and working with the knowledge transfer. That's kind of the infinite problem we have. That we're not starting with the problem, we're starting with the technology. Especially quantum disrupts so many industries quite fundamentally. So how do you go about in finding your first customers? How do you go about, or are customers at all relevant? Will it disrupt so much that you won't even know who the customer will be when the technology is ready? How do you sort of establish the needs in an early phase for these companies?
Yeah, it's always a challenge to get those first couple of customers on board. I think the state of quantum technologies right now is actually mature enough. And I'm looking right across the spectrum of technology areas, from sensing and metrology to communications and to computing. And I think it's fair to say that you have some early adopters in all of these areas. So you look at, for example, quantum computing, you have investment banks, financial institutions, they're quite interested in this. Also logistics companies, because they have very complex traveling salesman type problems that they need to solve. And quantum computers might offer an opportunity to provide a solution for this. For communications, you have interest from teleoperators that are looking both at terrestrial communications and satellite-based communications. And for sensing and metrology, I think the spectrum is even wider. It depends really on what sort of verticals you're addressing. But yeah, customers are available and can be found right across all of the technology areas.
That's maybe some of the things that you can get help with in an accelerator program, as you mentioned earlier as well, finding these industry partners that you need to maybe fuel development.
Absolutely. And the challenge is often getting into the right people within these organizations, because, if you take some of these multinationals, there are hundreds of thousands of people working for them. So to find that one person that is able to champion you from the inside and is able to make it happen within that organization and all the politics that goes on within it, that's the biggest challenge. And it's extremely time consuming, and you're not just going to be able to do that by cold calling the company and try to get through that way. So it's better to get those introductions from people who have gone through that journey before. As you say, some of these accelerator programs are good places in order to get those introductions. Often they accelerators program come with a group of mentors that come from these companies, and their role is to be technology scouts and interact with early stage companies, and those are the kind of people you want to be talking to.
Anyone working at CERN right now, or that have worked at CERN, that have an idea on how the tech they're working on could be commercialized, in addition to getting in touch with the knowledge transfer group, of course, what would be your kind of first, like, what's the advice for the first step? Like, before you even have a business plan, before you even apply to an accelerator program, there's a lot to be done before that.
Yeah, I think, as you said, and going back to the question about technology push versus market pull, it is about hypothesizing about what can this technology be used for, and I think it's good to get some validation from that. So. Talk to people about this to say, I have this great invention that I come up with in the lab. I think it can be good for A, B, and C. And go out and talk to people to say, do you think if I could build this, would it be interesting to you? And I think that is the kind of validation that you want, because you don't want to just do a technology push. In order for a company to succeed, you need to be able to match that technology with the market pull as well. So getting some early validation there, and you see whether people are interested in this or not, I think is a good first step. But that said, the knowledge transfer offices can help with that sometimes, and accelerator programs can help with that. And there are lots of like networking events that you can go to as well. It's all about making the right connections.
Yes, and the rule of thumb is that people are too busy to steal your idea, so don't be afraid to share it with people that might be able to help you. Right.
It's all about the execution, anyway. Yeah, the ideas are not that valuable. It's the execution of that idea that's really valuable. And if you have built something fantastic, then in all likelihood you're the best person to execute on that anyway. So
exactly,
that's absolutely right.
Yuri, thank you so much. I'm sorry.
Yeah, no, I was just agreeing with you. Yeah.
Okay, thank you so much. That's all we had time for. And thank you for joining this half hour of CERN Alumni Second Collisions. Are you interested in getting in touch with Yuri? You may contact him at yuri@nablaventures.com. And any questions regarding entrepreneurship at CERN may be forwarded to KT@CERN. Most likely, you'll hear from one of my former colleagues and our Entrepreneurship Development Officer at CERN, Ash Ravikumar. And you might already have heard about him or seen him at this event. And if the papers I have are correct, he is the one that I'm giving the word to now. We'll see.
Thank you so much, Lars. Thank you, everyone.
In the Quantum Technology and Innovation track, and I'm thrilled to introduce you to Daniel Verdu. Daniel is a data scientist engineer who specialized in image analysis using artificial intelligence. In 2015, he was selected as CERN summer student to join the ALICE Detector Control System group. In 2016, he joined the other students to create the Spanish Hyperloop UPV team and participated in the SpaceX Hyperloop competition. The goal was to design a scaled, real prototype of a futuristic transportation system to be tested at SpaceX facilities in Los Angeles. Daniel joined the project as technical director, leading a team of 30 students. The project was awarded as the world's top 8 best prototype, with more than 300 universities participating from around the world. In 2017, Daniel began to learn about artificial intelligence. He focused mainly on the computer vision area, and in 2020, he won the Computer Vision Spanish AI Hackathon with this solution for the Image Super Resolution Challenge. We have a 20-minute talk followed by about 10-minute Q&A. Thank you, Daniel. We look forward to hearing your talk.
Hello, everyone. Thanks for this perfect introduction to me. I'm very excited to be here again 6 years later. I've been in 2015 at CERN as summer student, And today I will try to explain the path I followed in the last years and why I've moved from developing control systems for robotics and automation processes to the design of new electric transportation systems, and finally to the implementation of artificial intelligence solutions on industry. All the decisions taken in this time have had the same purposes: being places where I could work and research in cutting-edge technologies and innovative projects that could have a positive return in people's life. As a child, I was a very curious kid, and my mind was plenty of questions that I had to answer in order to understand why the things were like that and not otherwise. This curiosity as a child was the seed of my passion for research, and it has served as a motivation for working hard in order to obtain the opportunity to be in places where biggest discoveries were taking place. So returning, I think it cannot work. Okay, perfect. Returning to my technical background, I have had a briefing of it here. I did a bachelor's degree in industrial engineering in 2010, because it was the most generalistic applied career I could study. For me, I prefer to know the basis of different fields instead of being a specialist in one of these. So I finished my degree in 2014, being awarded by my bachelor thesis as the best project in control engineering for designing and implementing control flight algorithms for drones using low-cost sensors. After my bachelor's, I continued my studies at the same university, and in 2015, I was selected as CERN summer student. For me, it was like a dream come true to be part of one of the best, largest scientific experiments that have existed in our history. And it was also the reward for all the hard work I put during my studies. In 2016, I returned to Spain and I joined the Hyperloop UPV project as technical director due to my generalistic technical profile. And our goal was to contribute in the development of a disruptive new transportation system. And finally, in 2018, I moved to a completely different field, that it was the artificial intelligence. I started to learn about artificial intelligence on my own because I was amazed by the first AI applications that were appearing and the enormous positive impact that AI could have on people's life. So during the last years, I have developed my career as artificial intelligence engineer focused on image analysis problems. And on March of 2021, I won the national hackathon, and it was the recognition for all the work I've done during years for developing myself in a new different field from I was doing. Yep. I think, can you show the next slide, please? Yeah. So now I want to talk about my work at CERN. What I did at CERN in 2015, I was selected for being part of the detector control system department of the ALICE experiment under the supervision of Professor Ombretta Pinazza. My goal was to develop a software that should be able to collect all the data coming from different systems that forms the ALICE experiment, and to categorize, analyze, monitor, and publish all this data to internet. So in this process, I had to develop all the software to aggregate all the information in XML files and publish as RSS feeds. So the software has to be able to publish information in regular intervals or when a predefined condition was satisfied. Can you show the next slide, please? Yep. So I want to talk also about not only about what I did at CERN, also to what I got from CERN. For me, looking backward, for me, CERN summer student was a life experience that changed my life completely and my way of thinking. Most of the people here have spent several years at CERN acquiring a lot of different technical skills. But however, I've been only 3 months there, but in the same way I learned other valuable things. Firstly, before I participated in the summer student program, I had never lived outside of Spain nor had any professional experience. So for me, CERN, some experience has formed me as a professional and made me grow as a person. At CERN, I live in a multicultural atmosphere where I meet people from different parts of the world that enrich my experience and awakened my interest in traveling and discovering new cultures. Secondly, I had the opportunity to work in high-performance teams from which I learned different work methodologies that I use nowadays. Thirdly, at CERN I met different researchers from which I learned their know-how and their passion, which make me a greater professional and researcher. And finally, this experience opened my eyes about the impact that research can have in our society. Certainly, it has inspired me to drive my work towards research so that it can have a positive return in society. For all of that, I think that CERN Summer Student Program is a once-in-a-lifetime opportunity, and I'm so glad I didn't miss it. And in 2000, after finishing at CERN, I was a bit overwhelmed about the next step to take in my professional career, and I decided to continue my studies at Leuven in Belgium. At that university, I had the opportunity to attend the lectures of an advisor to the European Committee on climate change policies, which made me aware of topics such as human carbon footprint and sustainability. So in 2016, motivated to participate in innovative projects and aware of these issues, I returned to Spain and I joined other students to create the Hyperloop UPV project as technical director. But what is Hyperloop? Hyperloop is a concept of a disruptive, high-speed and sustainable electric transportation system for both passenger and freight transport. It has 3 major components: a tube, a vehicle, and a terminal. And this transport concept has several benefits over conventional high-speed railways. First of all, it can reach higher speed. How? The vehicle travels inside a sealed tube with lower pressure. The air is extracted from the tube with pumps distributed along the tube in order to reduce the vehicle's air friction. As for putting numbers into this, the idea is to have 100 times less pressure than atmosphere. Besides, the vehicle is able to levitate from the ground while moving to reduce ground friction. So if we have reduced air friction of the vehicle and also we have reduced ground friction, Hyperloop could potentially move at airline speeds around 1,000 kilometers per hour. Secondly, a Hyperloop is a safer transport because it travels inside a controlled environment. As the vehicle moves inside a closed tube, all the influence of weather events like snow or thunderstorm is reduced. Besides, the closed tube makes that the vehicle is free of collisions during its performance, and also it prevents derailment. Thirdly, Hyperloop is proposed to be electric propelled, and it will have onboard batteries that will power the vehicle during the trip. Its batteries can be charged or replaced at the end of the trip, reducing the fossil fuel dependency of conventional railways. Additionally, the energy needed to pump out the air from the tube can be obtained from solar panels or wind turbines disposed along the tube, reducing human carbon also. The Hyperloop concept has its roots in 1800, and there have been many different technical proposals during history, but in 2013 it became a current issue again because Elon Musk published a paper called Hyperloop Alpha, when he argued how to connect San Francisco and Los Angeles with a new transportation system called Hyperloop. He argued that Hyperloop would be safer, cheaper, and faster than the high-speed railway alternative. With this transport, 560 kilometers of distance between both cities could be covered in 35 minutes. Besides, he published all the calculations made by his team and all the technical proposals for the different systems, both in the vehicle and infrastructure, in order to open the development to all the community. Some of the Hyperloop Alpha technical proposals were an actual compressor placed at the nose of the vehicle for transferring high-pressure air from the front to the rear. For propulsion, he said electric linear induction motors, where the rotor can be a simple aluminum blade. Regarding to levitation, he proposed air cushion to levitate the vehicle between 0.5 and 1.3 millimeters from the ground. And finally, he proposed solar panels on the tube as the main energy source. So, in 2016, Elon Musk organized a competition between universities around the world to build subscale prototypes in order to demonstrate technical feasibility of several aspects of the Hyperloop concepts. In words of Elon Musk, despite they were not developing a commercial Hyperloop, they were interested in helping to accelerate the development of a functional Hyperloop prototype. The competition took place at the SpaceX facilities in Los Angeles, and for the competition there was only one judgment criterion: reaching maximum speed with successful deceleration. I participated in this competition with the Spanish team, Hyperloop UPV, as technical director, leading a group of 30 students. In the image of the right, you can see our prototype that finally compete there. I have had some of the test track specifications we had to deal with. It was a tube that you can see also in the images of 1.68 kilometers length. As a result of the competition, our prototype was ranked as the top 8 best prototype of the competition among more than 300 different proposals from around the world. So, in 2017, I finished my participation in the Hyperloop UPV project, and I took some time off to think about which was the next step to take in my professional career. In 2018, I joined a Spanish company dedicated to the automation of industrial processes as computer vision engineer. My work was to integrate traditional vision solutions for quality inspection tasks. But after a little time, I started to hear how artificial intelligence solutions were emerging as an alternative for solving image analysis problems, improving traditional solutions. So, motivated by curiosity, I decided to learn what I could in my free time about AI systems focused on their use in image analysis problems. In my case, I did several online courses taught by prestigious researchers in the field just for free, thanks to the fact that nowadays all the knowledge is freely available on internet. And this is something for which we have to thank CERN as well. Firstly, for its contribution to the internet development, of course, and secondly, for its transfer knowledge policy, which has influenced the scientific community in a movement to open and share the science and the knowledge to the society. Returning to the AI topic, thanks to AI solutions, some of the visual inspection problems that were out of the scope for traditional vision systems have been solved, making a true impact in different applications and industry. Moreover, the use of AI on industry has improved the manufacturing efficiencies and has released the human force from performing repetitive and dangerous tasks, increasing their happiness and their job satisfaction. I have had some of the main AI solutions that are being used on industry for visual inspection. First of them is the example of an object detection system which detects if there is a clip or not. And in affirmative case, where it is and if it's well positioned, that you can see in green or not. The second example is a system called Optical Character Recognition for text recognition, because AI systems are good interpreting handwritten text or industrial text with shadows and poor lighting conditions without the help of any template. The system gives a score per character and per word, avoiding errors due to an error in a single character. And the third example is an example of an anomaly detection problem where the system is able to detect which component is different from the normal production. This technique is used when you are not able to reproduce all the failure cases or they are unknown. So besides the industrial applications, there are other interesting fields that I want to highlight where the use of AI solutions could have a major positive impact. So first of all is the healthcare, because with better data management and monitoring capabilities than humans, AI systems can be valuable tools for improving patient care, early diagnosis, and for accelerating the development of personalized treatments. The use of these tools can allow the healthcare professional to spend more time with patients and to reduce operational costs. In the first picture, it is shown how AI could be used to the early detection of breast cancer, which can make a difference between saving a life or not. The second of the images is an example of a project I work on, which consists in the detection of malaria infected cells to accelerate the malaria diagnosis. Actually, the protocol is to count manually how many red blood cells contain the parasite over 5,000 cells, which is a very slow process. So if we can use AI to accelerate, to boost this process, I think it can have a huge impact. Another example of where AI can have a huge impact is in the development of autonomous transportation, reducing the number of road deaths, reducing traffic congestion, and allowing to spend our time in different tasks. In the same way, AI is being used to develop a smart tractor, which can be used in agriculture to do the job without the human intervention. Yeah. Another example where AI can have a huge impact is in the photography and image processing. Most of the actual mobile phones that we use AI to identify objects and scenes, to adjust camera parameters like brightness or contrast, and to improve night mode photos. AI can be also used for upscaling image resolution while maintaining the realism. At the right, you can see the output of the AI model I used in a national hackathon I won in 2021. The challenge consisted of upscaling and painting pictures to images with 4 times more resolution than the low resolution original version. Another interesting applications could be image generation, data processing, also for helping people with disabilities, and there are a lot of them. And while the original goal of AI is to benefit humanity, there is also other applications that is a good negative impact society, as deepfake, where a person in an existing image or video is replaced with someone else's likeness, intelligent military weapons, or applications for the control of society. As you have seen, AI have infinite possibilities in so many different fields, and depends on us to use it for good purposes or not. At the moment, I'm still working on AI because it's huge potential for benefiting the people. Because at CERN, during my experience as summer student, I became aware of how important research could be for our society and for people, and I want to contribute and to put my effort to achieve this goal. So I would like to thank CERN and to all of you very much for the opportunity of telling you my story. And I would be more than pleased to answer any question you could have, so please do not hesitate to ask me.
Thanks, Daniel, for the presentation. It's incredible to see your journey over from summer student to Hyperloop and into AI. We've got a bunch of questions coming, and I'll try to get through those questions as much as possible in the next 10 minutes. The first question was, are you still in touch with most of the cohort from your summer student program that you were at CERN with?
No, no, not at all. And this is something important about the CERN Alumni Network initiatives. Sorry, I think I have problems with the audio. I have echo in my voice. Yeah.
How about now?
So,
Is it okay?
no, not solved yet. So the point is, I'm really open to contribute to initiatives for the CERN Alumni Network because I want to be more connected with people with similar interests like me, like the CERN alumni. For example, during the CERN second collision event, I had the opportunity yesterday to talk with another CERN students, not from my year, from other years, and also people with similar interests, and to share my doubts with others about the next step to take in your career, on how did you deal with different problems, and about how it was your experience. So I think all of us should put our effort to create a really strong network between us, because I think it will enrich our experience and all of us.
Thank you. Totally agree. For me, alumni represents that, right? So sum of all the different parts is bigger than the whole thing. So next question was, construction and maintenance costs for the Hyperloop, could they reduce the overall economic advantages of the Hyperloop?
I think that at this moment also the costs are very high, because the technology is not mature at all, but I think that the advantages are stronger than the disadvantage that they are at this moment. So, for example, one of the ideas that are on the table at this moment is to put all the technology on board of the vehicle to reduce the cost of the infrastructure. And regarding to the infrastructure, now it's expensive, but if we think about in the cost of high-speed railways like the maglev, could be similar at this moment. So as much as the technology evolves and develops, I think the cost will reduce, and also the advantage are still there.
Right. So to follow up on the question is, you are putting the infrastructure cost into the vehicle rather than putting, large electric lines that will have to feed the entire track. So track is less with Hyperloop.
Yeah. For example, for the only energy that you need for the infrastructure is for the pumps to remove the earth from inside of the tube, and it can be fed up by solar panels or wind turbines. So we can reduce. We don't need electric infrastructure, of course, and all the batteries would be on board of the vehicle. So we can reduce the infrastructure cost.
Oh, thanks, man. So, another question is, what's the framework that you use to find a project or a real-life problem when you're working with AI?
I work on industry, so for me, most of the challenge is to understand the process of our clients, to understand how the data is produced, their goals, what they want to do, and my role is to give them the information of what things they can do with the help of AI. So there is we can say a new field of interest, a new theoretical movement that you have put more effort in your. It's called data-centric, and it means that you have to put more effort in how do you obtain your data, how well is your data, how clean it is. instead of putting the effort in the model, in the architecture selection. So at the end, with good data, the rule of thumb for us is if your eyes can see it, I could build an AI system to detect.
One more question is on reliability and traceability of AI systems, the black box that you have to look at, how the AI system actually works. Do you look at it from a perspective of how do you look at whether the AI systems are, the results are traceable? Do you put that in the design process?
Yeah, there is an actual problem about AI systems that, for example, in most of the cases, they are black boxes that our clients don't understand. And there were different alternatives and different initiatives to put a bit of light in what the AI systems are doing. Recently, there appeared a new architecture called transformers that are being used also for image analysis. And one of the amazing results of the transformers used for visual analysis, it was that some cells, let's say, learn to recognize some different patterns, like the faces, like places. So you can interpret with transformer a bit more about which cells are being activated depending on the image and what they are learning. So the research is putting effort in understanding a bit more what is happening inside of the AI systems.
Thank you, Daniel. We wish you the very best for your future career, and thanks for taking time to participate and share your experience. Thanks. Good luck.
Thank you very much.
I had no questions.
Wow, what a fascinating afternoon we've just had. Thanks to all our speakers for such insightful and indeed inspiring talks. Now, coming up after the break, we have a very special presentation from Oliver James, Chief Scientist at the Oscar-winning special effects company, Double Negative, sharing the journey they went on to create the special effects in the Hollywood blockbuster space film Interstellar. Grab your popcorn, grab yourselves a drink, and we'll see you at 8 p.m. CET on the Esplanade.
Okay, super.